was going to do some testing today, but I can't do it because, well, I was still tired actually. I'm just really tired. I got up early this morning, but my friend wasn't able to drop the sofa off today, so and I also had to do a bit of shopping and stuff, and yeah, I'm just not feeling up to it today. I'm just tired, but I'll give you a sneak peek of it anyway. But there's some issues with it because I need to, obviously there's always issues. There's always something you've got to tweak and tune and everything else. One of the issues is that the nanocrystalline shielding on the back, oh, it's flipping charge lead is, right, so the hang on a minute, I've got to put this phone underneath the table because the wire's tangled up. Right, so the nanocrystalline on the back of the generator, because the magnets that I put in now are a lot stronger, we have a massive magnetic field now coming out of here. I'll show you that in a minute. Now, you remember previously when I was using my magnetometer, previously we had to get really close to the canopy, you know, when I was, but now we can get a field. We can get a field right here now. So it's a much stronger field. I'll show you on this side. Even with the nanocrystalline material on there, you can see how strong that field is. That's with both rotors now. Flipping thing, button's not working. Right, so if you look at the field now, you'll see that there's a very strong field now. It's too strong for the nanocrystalline, so the nanocrystalline material is now inducing a certain amount of drag. I mean, as in cogging. So I'm going to have to take that off actually and retune that, because that's got to be done. But what you will find interesting, I've got to switch this thing on actually. Hang on a sec. Let me just get this thing plugged in a minute. Hang on, I can't do it with that. Just a minute. Right, so it's just catching a bit on it. It's just catching a bit. Hang on a minute. I need to sort that out. Now this is what's going to be interesting. Oh, shit, that flipping... Oh, I can't, my elastic band's come off there. Yeah, I've got to do some work on it. Stop it, stupid thing. Hang on. Yeah, you can see why I need to delay doing proper tests. I've got some issues to work out. Damn thing's catching again. Alright, so this you're going to find interesting. Those are actual voltage readings. We have 30 volts peak to peak and 8 point... We're only running at 9 volts by the way. It's still picking up speed because it's catching at the moment. Bloody thing. I don't know where it's catching because... Oh, it must be that. Hang on. Oh, is it this one? I think it's this one. Right. Yeah, a bit better. So, yeah, those are the voltages. Pretty impressive, actually, because it's just one canopy. Just one canopy on it. We're not running at the maximum speed because of the nanocrystalline is creating a little bit of drag on it. So, it's dragging a bit. So we're only at 1000. We're still doing better. Now, if you remember the previous tests I was doing with the nanocrystalline cores, as in the segments, if you remember that test we did, oh, was it last year? I don't know. It was 6 months ago, 7 months ago, I don't know, 6 months ago. If you remember that test I did, I only got to about 800 RPM and I had a hell of a lot of cogging. The cogging was absolutely terrible on it. And that was when I was using the stator magnets. When I was using the stator magnets that were not moving, and the segments were moving, we had a massive amount of cogging problem with the stator magnets all the way around, populated with 3 magnets in each slot. Now, considering that we're running this at 9 volts, so that's the voltage. We're actually at 9 volts instead of 12 or 11 volts. So remember, previous test I was doing it at 11 volts, right? And we had a pretty low voltage. I forget what it was now. Was it 1.6 volts, I think, AC? Anyway, so we're running at 9 volts and we're just a bit over 320 milliamps, but it'll pick up speed eventually because the supercapacitors down here are still charging up as well. And this thing keeps catching. So it's dragging on it a bit. You can hear it clicking, it's catching somewhere. But we're doing really good. When we look at the peak to peak voltage, that's 36.2 volts and we're at cyclic 10.2 volts. What is interesting is that it's under load right now. I have a 1 ohm resistor. This way I'm tripping over it, hang on. So I've got a 1 ohm resistor down here. Right. I think it's a 1 ohm resistor. It's the 1.8 ohm resistor in series with a 1 microfarad metal film capacitor across the load right now. Now, what is interesting when I disconnect that is the fact it doesn't change on RPM. So we're at 1500 RPM. I'll disconnect this other 1 microfarad metal film capacitor, which is, what's the writing on it? We've rubbed it off, maybe. So there's this 1 microfarad metal film capacitor is in series with that resistor. Well, there's actually 2 microfarads in series with that load resistor right now. So I'm just going to disconnect one of these resistors. Let me just check the voltage. 10.4 volt cyclic, 1500. Right, so I'm going to disconnect one lead of this. So I've disconnected that one leg. Cyclic speed. It's not catching again now, it's stopped catching now. So you can see, it's pretty good that. Obviously, earlier I put a meter on it and it drew about 1.5 amps. But unfortunately it stalled it out because the flux is so strong right now that you need a certain amount of residual power in the coil from the capacitors to create that that counter drag effect. And if you fully discharge those capacitors to the point where there's no power left in them with a short circuit load, then what happens is I can't get this on, I'm trying to do this with one hand. If you short it out completely, because that nanocrystalline is not doing the job that it was doing previously. I can't get this on. Sorry, hang on a minute. It's easy to get it off, but it's hard to get it on. So, right, I'll put it back on there. We're at 10.2 volt cyclic. Speed, yeah, about same. Hasn't really changed. That's with 2 microfarads in series with that 1.8 ohm resistor, which is in parallel across the coil, which is basically shorting the coil out. And we have another 1 microfarad capacitor across the coil directly there. That's to store energy to keep the coil energized for the magnet motor segment array to help cancel the slowdown. There's quite a lot of air blowing out of here actually, so there's air getting in, which is also affecting it a bit. But so the plan of action is tomorrow. What I want to do is I want to take this nanocrystalline material off the back and do it air cored, because it will work better air cored now with that new arrangement of magnets. I really want to be able to show you the current when I short this out. Just a sec, let me just see if I can nick my leads off here. I'll get my meter leads. Hang on. Let's put this meter on the 10 amp range. I want it on AC. Stick my lead on the AC socket. Switch that on. Let's go over and do a short circuit, and I'll show you what I mean about it slowing down. It does actually when you short it out completely. So if I stick my meter there, this is going to be a bit awkward. How the hell I'm going to put both leads on that thing with one hand. Hang on. Yeah, as I said, this is a bit ad hoc today because I'm tired, and I'm going to go back to bed actually, because the soap is going to be delivered tomorrow instead. Yeah, because there was a problem, but it's alright. I need some sleep anyway, I'm tired. Right, where do I connect this? I've forgotten now. Oh, right, so I've got to put these meter leads. This is how we hold chopsticks, isn't it? So basically I'm going to hold the meter probe like you hold chopsticks. And I'm not succeeding. I can't do it. Hang on. This is crazy. Right, I think I've got it. Right, if I can get that on them. Oh, actually, where's my clip lead? No, I'll just try it this way. Are you watching the amps? We're on AC, we're on 10 amp range. Are you watching? Oh, what happened? It didn't register anything. Why didn't it register anything? Did I blow the fuse? Oh shit. Just a minute. Oh, I'm on volts, silly me. I want to be on amps. That's why. Didn't register because I'm on freaking volts. Right, so I'm on 10 amp range now. Right. Now I've got to be ambidextrous, whatever you call it, and get my chopstick hands back in position. Bollocks, I screwed that up when I right, if I can just, it's slowed down now. We've dropped right down to well, we're at 1500, right. Okay, so now it's starting to catch again. I'll do this quickly. Are you watching the meter? Shit. Damn it. Flipping thing's catching on me again. I'm not having a lot of luck today, am I? I'm on the 10 out range. One AC. I'm not having much luck trying to do this one-handed. Right. So. It's about 600 milliamps shorted out. Okay, oh my back, at least I got a rough idea. So it went up to 600 milliamps, but it slowed down as you could hear it. So that's because my nanocrystalline is not working, and that flipping canopy is catching again. Flipping heck. It's this one. Stupid thing. Right, so yeah, I decided to redesign those canopies, by the way, because I'm sick of them. The plan of action is to remodel the canopies, and instead of having the canopies on the inside of the hub, instead of having the canopies intersect the inside of this hub, I'm going to model them so they come on the outside of the hub. That will give me an extra millimetre. Oh, you can see why I decided to do this tomorrow, the proper test, because yeah, I'll give up. Flipping thing. Damn thing, I don't know where it's catching. All I can think is one of my segments is coming out. I've got a feeling one of my segments is coming out. That's the only explanation I can think of. That must be what it is. Weird. The tolerances are too tight, so if I do redesign, it means I've got to rewind all the coils though, and if I redesign the canopies, I've got to redesign the coils so over a wider area. Well, no worries, I'll sort that out, but I'm going to design the canopies, or I could chop the canopies in half and add a bit of extra plastic and thicken them out, widen them so that they come over the edge. So I've got, it's catching on the side, you see, not the front. It's catching on the side somewhere. I'll take them up and I'll be able to see the scratch marks where it's been catching. I'll figure it out. But anyway, that's what we've got. 37.6 volts peak to peak. Cyclic 10.6 volts. 10.6 volts. Yeah, and it's catching again. Anyway, I'm going. I'll sort this out tomorrow. You can see why I'm not doing a proper test today. It's just a quick, yeah. I'm just fed up with this damn thing. See you later.